Let's look at the first problem. For this quadratic function, fx equals to negative x squared minus 2x minus 2, you are asked to identify the vertex axis of symmetry, x-intercepts, y-intercept, if any, and also sketch the graph. So, to identify the vertex, we're going to follow the equation, the formula, that in order to write this original function fx equals to ax squared plus bx plus c into its standard form a x minus h squared plus k, we know that h equals to negative a b over 2a. So in this case, negative b is negative 2. 2 times a is negative 1, and that equals to negative signs. So these two negative signs cancel out, so eventually h equals to negative 1. And k equals to fh, which equals to f negative 1. We just need to plug in negative 1 into this equation to evaluate it, and that equals to negative 1 squared minus 2 times negative 1 minus 2, and that equals to positive 1 plus 2 minus 2 equals to negative 1. Therefore, the vertex is going to be negative 1, negative 1. The axis of symmetry is simply x equals to h, which is negative 1. Okay. Y-intercept is easy to determine. That's when you plug in x equals to 0. Therefore, y equals to 0, 0, and then negative 2. Therefore, the y-intercept is 0, negative 2. Now, we can try to sketch it, and we realize that the vertex is negative 1, negative 1. So the vertex is right here. Y-intercept is 0, negative 2. Y-intercept right here. And don't forget, and here, this is your axis of symmetry. Your graph will have to be symmetric about this straight line. That's x equals to negative 1. Don't forget the leading coefficient is negative 1. If the leading coefficient is negative 1, then the graph will be opening down. So it has a cup shape opening down. So based on this information, we realize that we can already sketch the function to be like this. And what that tells us is that there's no way this graph will have any intercepts with the x-axis, right? Therefore, in this case, x-intercepts simply, they don't exist. All right. Next problem, use synthetic division method to show that x minus 3 is a factor for the function. This is a third-degree polynomial function. So, and then after that, we need to find all zeros and sketch the graph as well. So for this third-degree polynomial function, when we use synthetic division to divide the original function by this factor, we put it in this format. We write down the coefficients only. If there's any missing term, then we need to fill in 0 for that coefficient. But in this case, we have third power, second power, first power, and then zeroth power. Therefore, we have no missing term. So we simply put in the coefficients 1, negative 5, 7, and negative 3. Now, for synthetic division, we don't divide this function by the factor, but we only write the 0 here. For a factor x minus 3, the corresponding 0 is x equals to 3. So we put 3 here, and then write down 1. 1 times 3 equals to 3, put it here. Negative 5 plus 3 equals to negative 2. 3 times negative 2, negative 6. 7 plus negative 6, positive 1. 1 times 3, positive 3, negative 3 plus 3, 0. And the remainder is 0, which is what we're looking for. Okay. And how to interpret this? This tells us that the original function equals to the first linear factor x minus 3 multiplied by a quadratic factor. We read these coefficients, x squared minus 2x plus 1. And then we need to factor this quadratic factor in order to find all zeros. And this is not that hard to find. This is simply x minus 1 squared, which tells us that we have 3 zeros. We have zeros x equals to 3, x equals to 1, and another x equals to 1. Therefore, x equals to 1 is a repeated root. It has been repeated twice. Okay, so k equals to 2. Okay, in this case, k is multiplicity. Okay, which indicates that on the graph x equals to 1, this x-intercept, we will have the graph of the function touching the x-axis but not passing through x-axis. Based on all these information, oh, and there's one more thing we need to find is the y-intercept, because we have already found the x-intercepts. For the y-intercept, again, plug in x equals to 0, y equals to 0, 0, 0, and then negative 3. Simply the constant term of this function. So with all this information, now to graph this function, we already know that 1, 0 is one x-intercept, and this one is special because x equals to 0 is a repeated root. Therefore, the graph will touch the x-axis here, but will not pass it. 3, 0 is another x-intercept. 0, negative 3 is the y-intercept. The leading coefficient is positive 1, therefore the right-hand side go up. The degree is 3, which is an odd number. The left-hand side tail will go to the opposite side, go down. Based on all this information, now we can graph our function to be so this is the sketch for this function, and this is the only way to sketch it, because as I said before, one of very common mistakes that students would make is that they will create new x or y intercepts on their graph that really were not calculated based on their analysis. So make sure that your graph will not pass the x or y axis at any other points. So that's this problem. The last problem, use long division method to show that x plus 2 is a factor for this function. You can pull out the negative 1, the leading coefficient, before you start the long division, but you don't have to. Let's just start directly. There's no missing term, so we just write the function here. For long division, we will write the factor here directly, and then to make this as close as the original function, we will multiply it by negative x squared to get negative x to the third power minus 2x squared. Then we do subtraction instead of addition like in the synthetic division, and then we realize that this subtract by this give you 0. Therefore, we have to write down the next two term. And then we realize that we have 0 here, but we will have a plus 1 right here to give you x plus 2. And then eventually, the difference between these two terms are 0 as well, which tells you that the original function equals to x plus 2 multiplied by negative x squared, no linear term, and then plus 1. Okay, in order to further factor this quadratic factor, again, let's pull out this leading coefficient to be negative x plus 2 x squared minus 1, which is not that difficult to factor, and this will give you x plus 1 and then x minus 1, and that will give you the 3 zeros corresponding to the 3 x-intercepts. X equals to negative 2, negative 1, and positive 1, no repeated root. And then to determine the y-intercept, simply the constant term, y-intercept is 0, positive 2. Based on all this information, we can graph the function x equals to negative 2, negative 1, and positive 1. These are the 3 x-intercepts. Y equals to positive 2, that is, sorry, these are the 3 x-intercepts, and y equals to 2 is the y-intercept. The graph, the function has a leading coefficient that's negative, therefore the right tail goes down. The degree is again 3 is an odd number. The left tail goes to the opposite direction, goes up. Based on all this information, we can graph it to be right tail goes down, passing through all the x and y intercepts that we just calculated. Left tail goes up, and that will be the graph for this function.